Okay, so this is learning task 2A for winter 2022 chemistry. Since now I'm going to have two assignments with the same name. So I ended up signing up for the molarity like in solution section. So that's what I did. So my first slide, obviously, and then come on, there we go. So I used to think final volume equals the sum of the reactants volumes. So for example, if you had 20 milliliters of water, and then you had, say, I don't know, 30 milliliters of milk. I just figured that when you add those together, you'd get 50 milliliters, for the volume measure of both of those put together. And then I also used to think that mixing a substance in solution changes the solution. Oh, actually, you know what? I keep trying to explain why that's not true, but that's the next one. So I'm going to wait on that. Because like visually, when you take like a substance and you put it in a solution, it sometimes it appears to like disappear, which is what I added here, which kind of influenced my original thoughts on what happens when you mix a substance in a solution. I also used to think that the N in the concentration formula equals mass when it actually equals moles, which I'll discuss more. And then I had a bunch of empty space, so I put a little chemistry photo there. Okay, so now I think, and in this section, I basically responded to what I used to think. So, in the previous section, I said that, adding 2 volumes would equal, final volume. But the reality is that there's no rule for volume like there is for mass, which is the rule of conservation of mass, which kind of states that, mass cannot be created or destroyed. So if you have 10 grams of a substance, you add it to 15 grams of another substance, the answer is going to be the sum of both of those put together. And what happens with this is that depending on how the reactants interact, the final volume may not equal the sum of the volume of the reactants, which also applies to the percentages, like how much of a percent of the total like a reactant makes up. And then when it comes to what happens when you mix a substance in with a solution, mixing a substance in a solution is also, it's almost like mixing a substance with a substance. Actually, it's not almost like that, it is like that. So in the case of water, you might, without knowledge of chemistry, you might just look at water and just see water is a liquid. It's just like how until recently, looking at milk, I didn't recognize it as, being milk, filled with molecules made up of stuff. It was just milk, So water isn't just a liquid, it's made up of H2O molecules, and depending on like the solubility of the substance that you add, those molecules will like float together and they may not interact, or they can interact and maybe exchange different like atoms or molecules, depending on what you put in there. But the components do not disappear. It's not like you mix like sugar in with water and the sugar is gone. You know what I mean? And then when it comes to the formula for concentration, the N part of it refers to the moles of a substance. So before I didn't really make that connection. I think I just used them interchangeably. When in reality, if a problem gives you the mass of something, say in grams, then you have to convert it not to models. I'll correct that. You have to correct it or convert it to moles before solving, or else it won't work. Even if your answer in the end is asking you to give it a mass amount, you still have to put it in moles in order to solve, and then you just convert it back in the end. So what do I want to learn next? I want to study like dilution and molarity in more volatile solutions. So I figure the same rules will be the same, but it would be interesting to get an idea of what the molecules are doing when you have, 2 volatile substances interacting with each other, or not even 2, because you can have 2 non-volatile substances, and when they interact, they become volatile. So how does this connect to my wider career? And I added personal goals in there. So this class is required for my biology major, in addition to being an optometry school prerequisite. So, I want to take it. But in addition, originally why I took this class in the first place is that I've always been fascinated with science as a whole, especially chemistry, even though I haven't had much experience with it until college. I have always been really fascinated with it. And in addition to this, I also really love lab work. That's always been like my favorite thing in school is labs. And so even if I don't make it to be a career, I want to learn everything about it, just because it's, it's been like my life's passion since I was 5. So what is something I'm still struggling with? So I found that sometimes I have a hard time understanding or interpreting word problems when they're not in the format I'm used to. And I've noticed this carries over to other subjects as well, like math as well. If the problem is worded or written down in a way that I don't usually see it, it's like all my knowledge just is gone. So I think I would like to see some of these problems written in other ways so that I can practice the critical thinking portion of like being able to understand the word problem. However, that does give me some anxiety because I have been notorious ever since I was young of having a really hard time understanding word problems, whether it's like an autism thing or what. Word problems have always been really difficult for me. So I want to get more practice on that, if anything, just to gain more flexibility with, going between different formats for problems. But without the stress of, like the first time seeing it phrased in different ways on a test, then it's like, what do I do? So yeah, so that's my presentation. Overall, I've really enjoyed this section. It was nice to review this stuff. What was interesting is this was a really hard section for me last quarter, so I was kind of putting it off. I wasn't really wanting to get back into it again. But once I did get back into it again, it became a lot easier for me, and I feel like I understand a lot better what it is, and how it works, how to do the equations, and all that stuff. So feel a lot better about it. I feel really good about taking last quarter's chemistry class in addition to this one, because it's allowed me to really better understand what I've learned. And I feel like that's going to do me a lot of good going into harder chemistry classes, as well as just more advanced science classes. So that's my presentation. Yeah, hope you have a good day. Okay, bye-bye.